So thank you very much, everyone. My name is Beda Barkokebas. So I have to be around here, this area. Fair enough. So thank you very much. My name is Beda Barkokebas. I'm here to present the paper with title Incorporation of Context-Based Data to Refine Machine Learning Models in Industrialized Construction. So we're going to talk a little bit about me, then what is industrialized construction in the context of this research. I'm going to present the research context and what's the research about. So you guys already know my name is Beda Barkokebas. I'm a Brazilian-Canadian living in Chile now. But I'm an assistant professor at UC Chile for the past 2.5 years. And I'm specialized in industrialized construction. For the context of this presentation, let's assume that industrialized construction is an approach in which building components are manufactured in a controlled environment and installed at its final destination. In my own words, this is where construction meets manufacturing, and there is a big potential for improvement, not only by automation of building activities, but also using data to leverage that productivity. And it's a great place to innovate. I'm biased to say about this, but it's a great place to innovate. Yeah, so the research context, I did my PhD in this factory in Canada. So as you can see, it has a fair amount of automation. There is a lot of data involved, CNC files, BIM models, schedules, material inventory. You have 2 automated machines, so for framing, for the boarding. And the wall panels, they are manufactured, assembled. In the case of a house, it takes between 6 to 9 hours to build the house. In the case of this building, which I worked during its construction, it took around 25 days to assemble the building. And one thing really cool about this factory is that they have a really cool RFID system. So in this factory, they have installed an antenna at the beginning of each workstation. So you can, and you have a tag for each panel. So basically you can know how long each panel is spent in each workstation, right? And you have the BIM models in which you have around 17 design attributes for each panel, area, length, number of connections, number of openings, and etc. You know, and part of my PhD was actually develop a cost model. So Beda, you have experience with dealing with data exchange with BIM models. You know machine learning, you're an estimator, so build me a cost model based on the actual duration times for those panels. So my initial objective was exactly to develop a model to predict the manufacturing times based on large sets of data. When I mean large sets of data, 2 years of data, more or less 27,000 panels, and also to evaluate the impact of automation. So I was really interested in knowing what's the actual impact of having a machine into the production line. We always hear great things about machines, but I wanted to know, I wanted to dig a little deeper about what are the impacts of those automations. So I had time studies, I had data for the actual times, I have BIM models. You know, I was developing those prediction models, and basically I got a design-based data set. I clustered those panels according to its design attributes to figure out which panels were the most similar. I did experiment with different clustering algorithms. I did do outlier detection with the workstation's times. I tried different regression models, doing parameter fine-tuning for each one of these models, for each cluster, for each type of model, linear, random forest, SVR, and the model failed. Yeah, so as you can see, there are values regardless of the type of cluster, like regardless of the cluster, the type of algorithm, the type of regression algorithm, the type of outlier detection method that I applied, I got really bad models that predict the manufacturing times. Right? So during my PhD, I said, what if I continue using those design attributes to predict the manufacturing times, but if I add more context about the production, right? And feed that into my model. But when my supervisor told me, you have a PhD you have a PhD thesis to finish, do that afterwards. And that's what I did. So that's what we're talking about, right? So I got my student, right, and get the RFID data and let's get data so let's extract data related to the production, not about the product. And let's incorporate that and let's see how that goes, right? So now we got the work in progress for the first 2 workstations, between workstation 2 and 3, and all first 4 workstations, which are the most automated ones. And then I added, on top of my modeling, those parameters. We created 2 different data sets for the first workstation, considering the work in progress for the first workstation and the following one, and considering the work in progress of all 4 workstations and the current workstation. And basically, what changed my modeling was first the clusters, because now I'm clustering the panels not according to its design attributes, but also according to the production attributes, right? And let's compare the results of those regression models between just design and now design plus production. Make sense? So, about the clusters, as we expected, we got a different number of clusters because now we have these different attributes that the clustering algorithms are selecting. Nevertheless, the most predominant design attribute remained the same, which is the number of openings. You have to consider that in the framing machine, the works, they have to stop to place the opening component. So that remained the most significant attribute during the clustering. But the second most predominant was actually the work in progress. Was actually right after design, the second one. So I had around 17 design attributes. The first one remained the same. The second one, production, right? And for the predictive models, we had a huge improvement, right? So comparing the R values from my previous model that is published, so I encourage you to actually read 2 papers now. We got a big increase, right? And the same, and the regression algorithms, so the random forest regressor remained the best performing, and the support vector regressor remained the worst performing, right? But we got a better improvement if compared just using design parameters to predict the manufacturing times. So just to finish, the main takeaways is that more context-based data significantly improve the prediction models. The results are actually consistent with other field studies that we managed to find, but be aware that those are still not reliable. Okay, so we got better predictions, but it's not reliable because they're way below what is acceptable, right? But this gives us a hint that, that's the path forward. Let's add more production data. Let's get more context from the production. And okay, let's continue considering the design attributes as we should, but this problem is far more complex than just getting the quantity takeoffs from the B models and connecting that to your time studies. So, yeah, so I think I'm right on time. Perfect. So thank you very much for listening to me. And yes.